Hello there, grade 10s. This is Mr. McCardle. I'm just going to show you how we do Pythagorean theorem problems with some circles. Okay, so here are the three circle properties you need to know. Angles in a semicircle. In a semicircle we always have a 90-degree angle. Wherever C is in this area here will always be 90 degrees. The chord is this straight line. The chord of a circle is a straight line joining 2 points on the circumference. Okay. If you then drop a line from the center, the bisector of that chord will pass through the center. Okay, the perpendicular bisector of that chord will pass through the center. Okay, or another way to think about it is that the line drawn from the center at right angles to the chord will bisect the chord. Okay. We also need to know about the fact that any radius from a circle will always meet a tangent at 90 degrees. So you can see how all of these are going to lead to right angle triangles. Here are the worked examples from the book, but I'm not going to go through those because you can always read through those yourselves, or you can use the self-tutor option if you're using the CD-ROM. These self-tutor buttons will talk you through the question. I'm going to work through this one here, just to give you one example at least. So I'm going to start by drawing a circle. Okay, there we go. So there's a circle, and we've got a chord of that circle has got length 3. So let's see if I can draw a straight line across that circle, and we'll label that to have a length of 3. There's my chord. The circle has radius of 4, so let's mark the center. Now the radius of the circle is length 4. So that means that this distance from here to here, which is also a radius, has a length of 4, and this line from here to here also has a length of 4. The shortest distance from the center of the circle to the chord, well, the shortest distance will always meet it at right angles. Okay, that's a point, that's a general statement, is that any shortest distance between any point and any line will always meet at right angles. Okay, this is the shortest distance between P and this line that I just drew. So we know we've got a right angle here. If the circle has radius 4, find the shortest distance from the center. So this is our x. This is the shortest distance from the center of the circle to the chord. Now, let's draw another diagram with just the right angle triangle that we want to work with. It's not drawn to scale, but that's okay. So this distance, the chord was 3. So this is actually just half the chord, the distance from here to here. So this is 1.5. The radius creates the hypotenuse here, which is 4. And this is our unknown. So substituting into Pythagoras' theorem, x squared plus 1.5, I'm going to write that as 3 over 2 squared, equals 4 squared, and then we've got x squared equals 4 squared minus, now 3 over 2 squared, we can evaluate that to simplify the calculation a bit. So 4 squared is 16, 3 squared over 2 squared, this is when we have a fraction with a power, we have to do the power to both the numerator and the denominator, so minus 9 over 4 is x squared. Okay, now just to speed things up, I'm just going to use my calculator for this. 16. Okay, I hope I haven't lost you. Okay, where's my calculator? There we go. So we do 16 minus. Okay. Everything works slowly when I'm recording. 16 minus 9 quarters equals 13.75, and then we want the square root of that answer, 3.7080999, so let's just say 3.7. Okay, so x equals 3.7 centimeters. Notice I took the square root there of the result of this calculation to get my x. Does that make sense? Well, the chord is 3, the radius is 4, the distance from... Yeah, that makes sense. This we'd expect this to be less than the radius. Okay, now I'm going to set you 3 or 4 other problems to do. Good luck with those. I need to try and work out how to stop this video.